Welcome to this lecture series, AS and A-Level Chemistry. In this lecture series, the first lecture will be on atomic structure. Before I go to atomic structure, I would like to let you know the books I will be following are as follows. Cambridge International AS and A-Level Chemistry course book, author Ryan Norris, and also another book, Pearson Edexcel A-Level Chemistry, author Curtis, Hunt and Hill, and other reference books when I start problem solving sessions. This slide shows structure of sodium chloride. I especially want to talk about it because this is the first X-ray crystal structure of sodium chloride, which was done in 1912 by Henry Breck, father and sons. I specifically want to say that there are two models here. One is space filling model and another ball and stick model. The sodium chloride and having sodium ion and chloride ions, how they are arranged, that has been shown in this structure. And to know about the structure, we know very many things about the properties of the compound, and therefore it is very necessary to deal the structures. And one more thing, that you have seen here how three-dimensionally the sodium ion and chloride ion are arranged. We might develop some defect, so to say, let's say one sodium ion is missing in this regular pattern, and one chloride ion is missing in this regular pattern, and thereby creating different types of properties, and that is what is a property of solid. And that could be engineered by scientists nowadays. Depending on the properties, they can engineer crystalline of some solid materials and thereby improving the properties as per need. So now I take the next slide where I talk about atomic structure, a little bit of history, and then go to the structure. The history, about 2,400 years ago, Greek philosophers, specifically Democritus, a well-known philosopher his time, coined the term atomos, which means indivisible. He was explaining, taking an example of iron and cutting a sheet of iron as little as he can, and then in one stage he could not cut any more, and that word in Greek word atomos, meaning indivisible. Such iron sheets, he said, that can be hooked together, imagining them making a large iron sheet. Democritus was a great thinker, but his idea failed because people did not take his theory, since he has got no convincing reason, or I should say he didn't have any experiment. That is also a philosophical thought. After about 2,000 years, European scientists purified substances, and they found substances could be broken into smaller substances that they call decomposed, and that small substances are elements. We know now there are about 118 elements. Elements combine together to form new compounds. In the 18th century, chemists began to make accurate measurements of quantities of substance involved in reaction. And to their surprise, they found that weights of elements which reacted are always in the same proportion. For example, water always contains 1 part of by-weight of hydrogen and 8 parts of by-weight of oxygen. In the beginning of the 19th century, John Dalton concluded that elements are made of indivisible particles. Dalton called them atoms. The ideas first proposed by Democrats. Dalton began to publish his atomic theory in 1808. The 5 main points of his theory are: all elements are made of indivisible particles called atoms. All the atoms of given elements are identical and have the same mass. The atoms of different elements have different masses. Atoms can combine together to form molecules. All the molecules of given compounds are identical. Dalton's idea was not taken graciously. Many scientists, however, could explain their results with the theory of Dalton atomic theory. Since then, after about 90 years, we could see that there are 2 points. One, atom is divisible, and the other one is atoms of the same elements are not identical. If atoms are divisible, what are the constituents of atoms then? 90 years of research finally resulted that atoms have 3 particles: electrons, protons, and neutrons. The experiments which we have done for discovery electron, neutron, and proton are a bit details which students can go through in books and find it out. But I'll just take the key points and let you know what was the findings. The key points were that Thomson, J.J. Thomson in 1897, investigating conduction of electricity by gases in Cambridge laboratory, and to his findings, he found that a negatively particle was about 2,000 times lighter than that of hydrogen atom. In 1904, he gave a model of atomic structure which is known as plum pudding model. But after then, in 1896, radioactivity was discovered. Ernest Rutherford in 1898 in Manchester discovered 2 types of radiation, one alpha and another beta. Though he didn't know what his alpha material is, but this heavy alpha radiation, they characterize and then with his co-workers Hans Geiger and Ernest Madison, a positive alpha particle passed through a thin gold film about 2 or 3 atom size thick. They were thinking that this alpha particle passed through the gold atom straight, but to their surprise they found some of the alpha particles are passing straight and a few deflected, and a very few just rebounded back. And that they concluded that there should be, in atom, there should be proton as well as neutron and electron. You can see in here the experiment designed by Thomson, and there's also the experiment designed by co-workers of Rutherford. When I was talking about Thomson plum pudding model, you see the plum pudding model structure here, and Rutherford's atomic model, which is known as Rutherford nuclear atom model. As soon as Rutherford published this, the Thomson plum pudding model was redundant. Rutherford nuclear atom model quickly replaced, as I said, plum pudding model. The work of Thomson, Rutherford and his colleagues are the following, which I have to show you one by one. First one is atoms have a small positive nucleus surrounded by a large space, empty space for the tiny electrons. The positive charge of the nucleus is due to the positive particles, which Rutherford called protons. Protons are about 2,000 times heavier than electron. The positive charge on one proton is equal to the same but opposite in sign is the negative charge and one electron. Atoms have equal number of protons and electrons as atoms are neutral, and the smallest atoms are those of hydrogen with one proton and one electron. Here I would like to at least say the size of an atom, and that is, if we take hydrogen atom, it is 10 to the power minus 10 meter in diameter, and size is so tiny that we can never see it by any microscope. Even a high resolution electron microscope, we could not see atom unless and until we magnify it in million times. However, that's 6 points, which is in slide. We go to the next slide and tell a little bit more about it. Rutherford, though, was successful in explaining the aspects of atoms, but a big problem remained. The big problem is that hydrogen atom contains one proton, as you know, and helium atom contains two protons. So the mass of hydrogen atom and mass of helium atom should be 1 and 2 respectively. But the mass is not the same, not 1 and 2, I would like to say. Hydrogen atom is less heavier, and helium is almost 4 times more than hydrogen atoms. Then comes another scientist who was working in Cambridge. He solved this mysterious problem by seeing a new kind of radiation, and that is he called as neutrons. Once we have all these summarized, we see that atoms are made of protons, neutrons and electrons. Now, where protons, neutrons and electrons are in atoms, that is another problems we have to explain. And if I go to earlier slide, according to Rutherford atom model, there is a positive charge, a very small space used in the atom, and the other outer space are for electrons. Next slide is, now we talk about the mass, relative charge, and positions of proton, neutron, and electron. The proton is a relative mass is 1 unit. So to say, neutron has got also relative mass 1 unit, but an electron, as we said, that about 2000 times less than that of proton. If we go for charge, we said proton is positively charged, neutron has got no charge, and electron is negatively charged. And then the positions of these proton, neutron, electron, we see that proton and neutron are in the nucleus of the atom, electron are in different shells of the atom. I have a symbol of potassium, which one can also place here as an X, and then one superscript and another subscripts. In the subscripts, you are seeing number 19, and in superscript, you will see that it is 39. We have to explain this now. 19 is the proton number, and the 39 is the mass number, or we call it nucleon number. The number of protons are designated by Z, and number of neutron and proton is designated by A, which we call mass number. So one can look into this symbol or other symbol for any other atom. One can easily find out the number of electron, proton, and neutron. You see, every element has got a unique number of proton. For example, hydrogen has got proton number 1. If we go to helium, it is proton number 2. And if we go to next, then it is 3, 4, 5, etc. I told previously that there was a dilemma that if helium has got proton number 2 and hydrogen has got proton number 1, their mass should be relatively 1 and 2. Do remember that hydrogen has proton number 1 and electron number 1 also, but there is no neutron in hydrogen atom. But in helium, we have 2 proton number and 2 electrons as well as 2 neutrons. And that explains why hydrogen is 4 times less heavy than that of helium. This we would explain more with very many examples. And this is all for today. I hope you enjoyed this lecture, and hopefully you will attend my lecture series by signing up the following link. Thank you.